For a century, the automotive industry operated on a simple, physical divide. Automakers built the cars, and franchise dealers sold them. This diagram illustrates the traditional life cycle of a vehicle. Information moves in one direction. The manufacturer passes the physical asset to the dealer, and the dealer hands it to the customer. But the data generated at each step hits a hard stop, trapped by competing business models. When a dealer tried to report back on a repair or a shift in customer preferences, the information was delayed, heavily filtered, or entirely lost in the friction of the handoff. The entire economic structure of the industry actively rewarded hoarding information and penalized sharing it. By 2028, the technical barriers to solving this had vanished. Automakers possessed massive data lakehouses, open APIs, and millions of connected cars transmitting gigabytes of telemetry every hour. Yet for 4 solid years, this massive intelligence infrastructure sat largely dormant. The pipes were fully built, but nothing flowed through them. The bottleneck was human. Dealerships looked at the manufacturer's request for data and saw an extraction scheme, a way for the automaker to eventually bypass them and steal their proprietary customer relationships. Meanwhile, manufacturers viewed their franchise networks as black boxes. They couldn't see real-time market demand on the showroom floor, forcing them to build cars based on outdated quarterly projections. Scaling AI across the industry requires solving for organizational trust, an obstacle that proved far more resilient than any software bug. In 2032, a few progressive partnerships rewrote the rules. They stopped treating data as something to be extracted and started treating it as a raw material for mutual value creation. They established ecosystem governance. These were new legal and economic agreements that allowed independent businesses to pool intelligence without sacrificing their competitive positions or violating customer consent. Manufacturers guaranteed that if a dealer shared localized market signals, the dealer would receive predictive analytics capabilities in return, powerful tools they could never afford to build on their own. With the economic incentives finally aligned, data immediately began to flow through the massive technical infrastructure built years earlier. Looking at this diagram of the 2032 network, we can see the exact mechanics of this shift. Instead of a linear handoff, a single piece of vehicle telemetry now radiates outward. That data pulse hits the manufacturer instantly, allowing them to monitor fleet quality and tweak production lines on the fly. At the exact same millisecond, that identical signal reaches the local dealer, triggering a proactive service alert before the driver even notices a mechanical problem, and it pushes directly to the customer's app, presenting clear, transparent maintenance needs. Real-time demand signals from the showroom floor now route straight back into the factory's production planning, completely bypassing the old system of delayed quarterly reports. Erasing the transactional handoff turned isolated, stale data points into a continuous, living stream of intelligence. This chart demonstrates the economic fallout of integration. As predictive interventions rise, ecosystem-wide warranty costs plunge. Parts are replaced before they fail. Overlaying new data, inventory carrying costs crater. Factory production tightens to match localized demand. Customer lifetime value increases because drivers experience a seamless relationship with the brand, supported by highly personalized, proactive service from the dealer. Because every dealer now shares precise demand signals with the manufacturer, parts logistics networks can position inventory in local hubs weeks before a vehicle sends its first failure code. This removes the need for expensive, last-minute emergency shipping. Systemic intelligence sharing proved to be an overwhelming competitive advantage. Companies still clinging to isolated adversarial data models simply could not match the efficiency of a connected ecosystem. The automotive value chain now functions as a distributed neural network, a system where thousands of nodes process information in parallel to achieve collective intelligence. After a century spent optimizing individual corporate fiefdoms, the industry was finally optimizing the collective system. But this interconnected structure raises a critical question. When a unified intelligence network begins making optimization decisions globally, what happens when it starts thinking faster than its human managers can oversee?